To Pramod Nainapalli YouTube channel. Today I am going to discuss about mechanism of antianginal agents. In my previous video I have discussed about chemical classification of antianginal agents. Please go through with the link that has been shared in the comment box. Okay, today we discuss about mechanism of antianginal agents. To know this mechanism of antianginal agents, we are having majorly in the discussed previous, as we discussed, we are having major drugs like nitrates, class of drugs, beta blockers. Third one is calcium channel blockers. Fourth one is potassium channel openers. These are the four major class of antianginal agents. I am going to discuss the mechanism involved in the nitrates, calcium channel blocker and potassium channel openers in antianginal. Beta blockers we will discuss majorly in the antihypertensive. In my next videos we are going to discuss about beta blockers in antihypertensive. There we are going to discuss the mechanism associated with the beta blockers. Now we discuss the mechanism involved in nitrates, calcium channel blockers, potassium channel openers. Now to know this mechanism, first we have to know what is a basic mechanism involved in the myocardium contraction. Generally we know that angina pectoris is caused due to the chest pain. It is majorly caused, it will lead to the symptoms like chest pain. Why you get chest pain means when smooth muscle myocardium get contracts, then you get a chest pain. So now myocardium contraction, how it takes place generally, then where the drugs will act. Now generally if you see the smooth muscle membrane, in the smooth muscle extracellular you can find a calcium. Okay, so this calcium gets entered inside the cell. Which cell? Smooth muscle of myocardium. They enter inside the cell, they will be stored, and once they stored they will release this calcium. What is that? Calciums have entered through the channel. This is a channel is opened. So this is a L type of channel. What type of channel this is? Particularly the calcium entry is an L type of calcium channel. There are L type, T type. We are having different types of channels, of ion gated channels. So calcium is L type of channel. Now this calcium get entry inside the cell. They are stored and released. And once they are released, they are combined with calmodine. CAM means calmodine. Now they are combined with calmodine. And what happens means inside the cell, that is cytosol of smooth muscle. This is a cytosol. What it is? It is a cytosol. Okay, so cytosol inside the cell is a cytosol. Inside the cell cytosol, what happens? Calcium combined with the calmodine, they will phosphorylate. What means? Myosin light chain kinase. MLCK means myosin light chain kinase. So MLC. So what happens? This is inactive. Myosin light chain kinase is inactive. They will convert into phosphorylated active form. Myosin light chain kinase. They will get phosphorylated P. Now what happens? This will phosphorylated converts the molecule called as myosin to myosin phosphorylated. This myosin phosphorylated plus actin combined together, they cause the contraction of blood vessels. When they cause the contraction of blood vessels, you get a pain, you get a chest pain. So that is called as an angina. You get a angina. One way is a calcium entry leads to this way. The other method is by using Gonal Cyclase. So Gonal Cyclase pathway is there. What does this Gonal Cyclase pathway do? Means Gonal Cyclase pathway activate cyclic GMP, cyclic guanosine monophosphate. This will phosphorylate myosin light chain kinase into myosin phosphorylated. So when it get phosphorylated, what happens? They will get contraction. They will result into contraction by this process. Myosin will convert into myosin. Myosin will combine with the actin, and finally it leads to the contraction. So this is an overall mechanism of contraction. Now where does this drug act? Where does the nitrates act? So nitrate will act by inhibiting. What they inhibit means they generate nitric oxide. Nitrates, you see that what they do means they will generate nitric oxide. So nitric oxide is very toxic. It inhibits cyclic GMP or Gonal Cyclase. When it is inhibited, there is no phosphorylation. No phosphorylation means no contraction. The smooth muscle get relaxed. The smooth muscle will get relaxed. So like this, what happens? Nitrates inhibit the cyclic GMP, secondary messenger. So inhibit Gonal Cyclase pathway. Thereby there is no phosphorylation, no combined with the actin, and no contraction. The relaxation of smooth muscle takes place. So this is a one way of method, one way of class. The other class is calcium channel blockers. They directly block the calcium entry of calcium channel. So this is calcium channel blockers, verapamil. Okay, so I have given you the classification, you go through. So they will block. When it is blocked, there is no entry of calcium. When there is no entry of calcium, calcium will not, myosin will not get phosphorylated, combined with the actin and cause contraction. Because there is no entry of calcium. Calcium inside the smooth muscle means it results into the contraction. But what happens? Calcium channel blockers, they block the L type of channel, iron gated channel. So they prevent the entry of calcium inside the cell. No calcium is there inside the cell. No calcium means instead of calcium result into the contraction, but no entry of calcium, it causes smooth muscle relaxation. It causes the smooth muscle relaxation. So these are the two mechanisms we can see in this schematic representation. So if we come to the point of potassium channel openers, this is in the second diagram where you can understand potassium channel openers. So what is this potassium channel openers? Now you see here potassium channel membrane is there. Okay, inside the cell cytosol, this is outside the cell extracellular fluid. So membrane means lipid bilayers are there. One is you are having potassium channel. Okay, one is you are having potassium channel. The other is L type of calcium channel. Okay, so on the beside the L type of calcium channel, you can see here calcium channel you are seen. So beside the calcium channel, you can see that the potassium channel. So calcium channel is there, potassium channel is there. Now what happens means the potassium channel opener, now it is closed. This black, what I have indicated, it is what it is. It is closed now. It is like a key for the lock. Now it is closed. Now what happens when you give nicorandil, the drug potassium channel opener? I have given you the class. Okay, what they do means they will open this particular thing, nicorandil. Now the gate is closed. You think that this is potassium channel gate is closed. Now when gate is closed with a lock, this is a lock, black one indicates the lock. Now it is closed. Now nicorandil opens, that's why it is a potassium channel opener. Okay, nicorandil opens this particular key. Now when this particular key is opened, it will go and bind to the calcium channel. So the key is transferred from ear to the ear. Now calcium channel which is opened previously will get closed. Potassium channel which is closed will get open. So potassium channel openers means they open the potassium channel. As a result, potassium inside the cell will go to the extracellular fluid. Calcium outside the calcium inside the cell, it will come inside the cell, but it is closed. Means calcium entry is closed means there is no contraction, there is a relaxation. So potassium will go outside, calcium entry is prevented. Inhibit calcium entry. So calcium entry is inhibited means we have seen if calcium is not entered means what is going to do means it will cause relaxation. Indirectly the calcium channel is blocked. How it is blocked? The key of potassium channel gated receptor which is there on the membrane are been opened, and this key will go and close. So as a result, what happens? Potassium which is inside the cell will come outside the cell, okay, and the calcium which is are entering opened, now it is closed. So it cannot come inside the cell. Inside the cell is inhibited. Now calcium entry is not there means it will cause the relaxation. It will cause the relaxation. It will cause the relaxation. So this is a potassium ATP dependent channel. What it is? Potassium ATP dependent. The outgoing of potassium depends upon the energy source, that is ATP. That's why we call it as a potassium ATP dependent channel. So what happens? The ATP helps so that Nicorandel will open this key, and this key, when it is opened, the gate is opened. As you know that gate, how it will open, like that it will open. Potassium inside the cell will go to the outside the cell. Calcium which used to previously enter inside the cell, blocked. Calcium is blocked. We have seen in the previous mechanism that calcium was inside the cell means it caused the contraction, you know. Now inhibition of calcium entry taking place. So gate is closed, calcium channel gate is closed. How it is closed? By opening the potassium channel gate. When gate is opened, the other gate is closed. So opened gate, potassium will go away. Potassium should not stay in the cytosol, it should go outside. When it goes outside, it will cause hyperpolarization. What is this hyperpolarization? You know very well, and I don't take much of the things about hyperpolarization. Now increase in the polarization takes place. This will go outside. Membrane hyperpolarization takes place. Membrane hyperpolarization in turn causes the relaxation of smooth muscle. Thereby what happens? It will act as an antianginal. It will reduce the chest pain. It will reduce the angina pectoris. This is all about the mechanism of anti-anginal agents. In my next video, we will be discussing about other cardiovascular diseases we are going to discuss. So this is what for the today's discussion, our discussion. Mainly thing, the contractions are caused due to the influx of calcium ion. This you should know, influx of calcium ion. And also contraction takes place because the potassium ion is in the cytosol. So potassium must go outside, calcium inside must be inhibited. Potassium must go outside, whereas calcium entry must be inhibited. If you inhibit this mechanism, this nitrates, calcium channel blockers and potassium channel openers, they act like this particular mechanism. Thank you, one and all.